Wireless security protocols were developed to protect home wireless networks. These wireless security protocols include WEP, WPA, and WPA2. In addition to preventing uninvited guests from connecting to your wireless network, wireless security protocols encrypt your private data as it is being transmitted over the network, something we all want.
Absolutely.
Wireless networks are inherently insecure, and in the early days of wireless networking, manufacturers tried to make it as easy as possible for end users. The out-of-the-box configuration for most wireless networking equipment provided easy but insecure access to a wireless network.
Now, although many of these issues have since been addressed, wireless networks are generally not as secure as wired networks. And this is because wired networks, at their most basic level, send data between 2 points, point A and point B, they're connected on a single network cable. Now, wireless networks, on the other hand, broadcast data in every direction to every device that happens to be listening within our limited range, like we talked about. The following are descriptions of the WEP, WPA, and WPA2 wireless security protocols.
Yes. So wired equivalent privacy, or WEP, was the original encryption protocol developed for wireless networks. As its name implies, WEP was designed to provide the same level of security as wired networks. However, WEP has many well-known security flaws, is difficult to configure, and is easily broken.
That's right. Wi-Fi Protected Access, or WPA, was introduced as an interim security enhancement over WEP. Now, this was while 802.11i, a wireless security standard, was being developed. Most current WPA implementations use a pre-shared key, or PSK, commonly referred to as a WPA personal and the temporal key integrity protocol, or TKIP, for encryption. WPA Enterprise uses an authentication server to generate keys or certificates.
That's right, and Wi-Fi Protected Access version 2, which is WPA2, was based on the 802.11i wireless security standard, which was finalized in 2004. The most significant enhancement to WPA2 over WPA is the use of the Advanced Encryption Standard, AES, for encryption. The security provided by AES is sufficient and approved for the U.S. government to encrypt information classified as top secret, so meaning it's probably good enough to protect your secrets and my secrets.
I hope so. It's protecting our government secrets. WEP has 3 goals to achieve for a wireless LAN: confidentiality, availability, and integrity. Now, WEP is now considered insecure for many reasons. Nonetheless, it did serve its purpose for a certain amount of time. WEP uses encryption to provide confidentiality. The encryption process is only between the client and the AP, meaning that packet transfers after the AP, the wired LAN, are unencrypted. WEP uses RC4 for encryption purposes. Since RC4 is a stream cipher, it needs a seed value to start its key stream generator. This seed is called the initialization vector, or IV. The IV and the shared WEP key are used to encrypt and decrypt transferred packets. In the encryption process, the integrity check value, ICV, is computed and attached to the payload. Then the payload is XO-read with the encryption key consisting of 2 sections, an IV and a WEP key. The packet is then forwarded with the IV value sent in plain text.
Yes. WEP uses CRC, cyclical redundancy checking, to verify message integrity. On the other side, receiver AP, the description process is the same but reversed. The AP uses the IV value sent in plain text to decrypt the message by joining it with the shared WEP key.
That's right, Laura. And then WPA contains enhancements or replacements for the following security features. You ready? Authentication, encryption, data integrity, and authentication. With 802.11, 802.1x authentication is optional. With WPA, 802.1x authentication is required. Authentication with WPA is a combination of open system and 802.1x authentication, which uses the following phases.
Yes. The first phase uses open system authentication to indicate to the wireless client that it can send frames to the wireless AP. Now, the second phase uses 802.1x to perform a user-level authentication. For environments without a radius infrastructure, WPA supports the use of a pre-shared key. For environments with a radius infrastructure, WPA supports EAP and radius.
With 802.1x, the rekeying of unicast encryption keys is optional. Additionally, 802.11 and 802.1x provide no mechanism to change the global encryption key that is used for multicast and broadcast traffic. With WPA, rekeying of both the unicast and global encryption keys is required. The Temporal Key Integrity Protocol, TKIP, changes the unicast encryption key for every frame, and then each change is synchronized between the wireless client and the wireless access point. For the unicast global encryption key, WPA includes facility or a faculty for the wireless access point to advertise changes to the connected wireless clients.
Yes. For 802.11, web encryption is optional. For WPA encryption, using TKIP is required. TKIP replaces web with a new encryption algorithm that is stronger than the web algorithm, yet can be performed using the calculation facilities present on existing wireless hardware. TKIP also provides for the verification of the security configuration after the encryption keys are determined. The synchronized changing of the unicast encryption key for each frame, and the determination of a unique starting unicast encryption key for each pre-shared key authentication.
WPA defines the use of the Advanced Encryption Standard, AES, as an optional replacement for web encryption. Because adding AES support by using a firmware update might not be possible for existing wireless equipment, support for AES on wireless network adapters and wireless access points is not required. 802.11 and WEP data integrity is provided by a 32-bit ICV that is appended to the 802.11 payload and encrypted with WEP. Although the ICV is encrypted, it is possible through cryptanalysis to change bits in the encrypted payload and update the encrypted ICV without being detected by the receiver.
Yes. With WPA, a method known as Michael specifies a new algorithm that calculates an 8-byte message integrity code, MIC, with the calculation facilities available on existing wireless hardware. The MIC is placed between the data portion of the 802.11 frame and the 4-byte ICV. The MIC field is encrypted along with the frame data in the ICV. Michael also provides replay protection through the use of a frame counter field in the 802.11 MAC header.